welcome to Leading Entrepreneurs of the World. I'm Stelios Hatzakis, CEO of One Business World. Leading Entrepreneurs of the World features entrepreneurs, founders, and business leaders presenting on cutting-edge topics and the latest industry developments. Today, we're very pleased to welcome leading global entrepreneur, Gediz Karaca. Gediz Karaca is the CEO of Odqa Renewable Energy Technologies, where he and his team develop the cheapest on-demand solar power. Gediz has many years of mega project construction management experience and has led the development of over $1 billion of assets, including the development of complex engineering projects, such as water supply systems, subway stations, skyscrapers, and bridges. Odqa Renewable Energy Technologies, which is a venture-backed engineering spin-out from the University of Oxford, is developing a new solar thermal system by applying aerospace technology to build a state-of-the-art solar receiver. Through this innovative design, the Odqa system is nearly 50% more efficient compared to current commercially available systems and enables carbon-free combustion level temperatures for industrial processes and electricity production cycles. Gediz, we're very happy to have you here with us today to hear more about dispatchable solar power and about your and your team's efforts in developing groundbreaking technologies and the one-of-a-kind high-temperature solar receiver that can control and move heat on scales large and small. Welcome to Leading Entrepreneurs of the World.
Thank you for having me, Stelios. It's a pleasure to be here and explain everyone what we are doing in Odqa. So, as Stelios mentioned, I'm the CEO of Odqa Renewable Energy Technologies. And Odqa is a spin-out from University of Oxford, more specifically from Oxford Thermofluids Institute. It is the largest engineering institute in the University of Oxford. And in this institute, it is developing very cutting-edge technologies like jet engines, aerospace technologies, or rocket technologies. So it is a very important strategic investment in the United Kingdom. And we develop our technology using this knowledge base. And what we are doing is we are reconstructing the sun on the face of Earth. So let me explain this topic a little bit further. As you might know, the sun is a free fusion reactor, and it will be available for the next billions of years. The surface energy flux on the sun is extremely high, 63 megawatts per meter square, and the temperature is really, really high as well. So we receive on the face of Earth, we receive around 1 kilowatt per meter square. It is a very diluted energy, and the average temperature is 25 degrees C. So what we are doing is we are concentrating this sunlight to some 2,000, 3,000, 4,000 concentrations, and we are reconstructing the sun on the face of Earth. Because if you look into fusion reactors, they need to have millions of degrees of Celsius temperature. So it is a very challenging task to replicate a fusion reactor. Whereas our technology, we are increasing the temperature up to 1,500 degrees C, and it is significantly easier. That's why we are using the sunlight. We are concentrating the sunlight, and we are producing a very hot substance which can replace the combustion that we are using every day. Let me introduce the team, the management team, the core team, and I would like to start with Professor Peter Ireland, because he is the mastermind behind our technology. He is the head of Oxford Thermofluids Institute, where in which there are like more than 100 researchers working on broad portfolio of technologies. And those technologies, they are heavily funded by some really large corporations, and they are using this facility as their back office to do some extremely challenging research. So Peter is one of the co-founders of Odqa and co-inventors of our technology, and he is the mastermind behind our journey. In our journey, one of the main things that we are doing is transferring the knowledge base of jet engines and gas turbines into renewable energy. Because gas turbines and jet engines, they need to burn something to operate. So they are inherently quite dirty technologies. So we need to decarbonize that. And we invested incredible amounts of money in jet engines for the last 70 years. So transferring this knowledge base is crucial, and this is our mission. And let me introduce another very, very important engineer in our company. So Dr. Ed Wood joined our company last year. And right now he is working full-time as Chief Technical Officer. He worked in motorsports industry for the last 25 years. And in the last 12 years, he was the chief designer of Williams' Formula One team. So he was responsible of all the mechanical things, all the aerodynamic things, the engine, the materials, the aerodynamics. So he's a superb engineer, and we are very lucky to have him on board. Me and my other co-founder, Ahmed, we are responsible of the commercialization of the technology, the ideation of the product, and the development of partnerships. So this is the team. We have other extremely talented engineers, but at this stage, I don't want to go into details of them. So what this team, this all-star team is doing, we are looking into the picture right now. In this picture, we see the global energy mix and the forms of fuels that we are using to fuel that operations, I would say. And there are some less interesting things from my point of view, and some very, very interesting things from an engineering point of view. And less interesting things are like low temperature operations. For example, at your houses, you burn gas or you use electricity to heat up your house to 80 degrees C, 90 degrees C. They are, from an engineering standpoint, they are less interesting because you can reduce the use of the fuels significantly by introducing good insulation practices. So it's not the most challenging issue that you want to solve. That's why it's less interesting from our point of view. So as I said, the more interesting bits are electricity is very interesting, and high temperature heat, it is very interesting because right now, for example, for the production of ceramics, production of cement, production of steel, we don't have a technical solution. What we only have is we burn fossil fuels, we burn gas, we burn oil, we burn coal, and we heat up this material up to extreme temperatures, 1,000 degrees, 1,500 degrees. And this is the only way we can continue producing those things. So there are no viable alternatives. So from my point of view, this is extremely interesting because from a technical point of view, it's not impossible to do it. So you can develop products for this. And this is what Odqa is doing. This is what excites us, all of us. And for electricity, as you can see, we have clean resources bundled up all together, and we have gas and coal. The majority of these clean resources are not wind or PV panels. The majority of this is coming from hydroelectricity. So it's a very good resource. We use it all the time, and nuclear is considered one of the clean sources. The challenge of having the challenge of replacing gas and coal is quite an quite a steep battle, uphill battle, because gas and coal, they are dispatchable in nature. So it is extremely easy to store them, and you can use them during the night, during the day, whenever you like it. So they are dispatchable, so they are on demand. Whereas wind and PV panels, they are not dispatchable at all. When the wind blows, you are good. When it doesn't, they don't produce anything. And at your homes, you don't want to have you don't worry about turning on the electricity and thinking about it basically. So the loading and the supply and demand must match all the time, 100%. So the challenge in electricity is matching the demand perfectly, and that is why replacing gas and coal is not a trivial thing. You cannot replace gas with PV panels. Instead, when you put 1 megawatt of PV panels, you need to have 1 megawatt of gas for the corresponding loading during the night. So it is the PV panels, when you put more PV panels, it is making more expensive to generate electricity because you are only utilizing your gas power plants only during the night. So you are reducing the utilization. Okay, I don't want to go into more details, but this is how we see it. And this is quite an interesting challenge for us, and we are determined to solve it. So how to solve it? Concentrated solar power is a very new field of engineering. The first commercial tower-based CSP plant started its operation in 2008. So it's a very new field of engineering, I would say. In this field, what we do is we have mirrors, thousands and thousands of mirrors instead of PV panels. And these mirrors reflect the sunlight to a central tower. And at the top of the tower, we have an engineering marvel, I would say, a challenging machinery, which is the solar receiver, central receiver. This machinery is, from an engineering standpoint, it is at least 10 to 20 times more challenging compared to any components of this power plant, because it needs to deal with all the energy coming from thousands and thousands and thousands of mirrors at a very small space. So the heat fluxes it experiences are, I would say, at least one order of magnitude higher than what normally you see in an ordinary machinery. So they are special machinery, and yeah, from that machinery you generate heat right away. And the beauty of heat is you can store this heat in various materials, and you can insulate it. And this is, from the cost perspective, this is 20 times cheaper than electrochemical batteries. So the beauty of this plant type, and the main unique selling point, I would say, is the fact that you can generate power or energy from the sunlight, and you can store it in the form of heat rather than electricity, which is extremely cheaper than electrochemical batteries. So once you have this stored energy, you can use it. You can use turbines, the extremely developed kind of technology we are using for the last 100 years and generate electricity, or you can use it as heat and replace combustion. So this is just a graph showing that actually you need to replace gas, coal, and since this is the base load energy need, this is the base load power need, it is very challenging to replace it with PV panels and wind turbines, and people don't get this distinction. Of course, it's a technical detail, but it's an important one. So if you add this and look at the problem from a cost perspective, PV panels are getting extremely cheap, which is a great thing for us, for humanity. I love them. The wind turbines, I love them as well. They are great. But if you add the cost of the battery on top of them, they are very expensive. We need to replace gas. And if you want to replace gas for the purpose of electricity production, it has to be cheaper than 5 cents per kilowatt hour. Like this is the benchmark. And with our technology, we will be cheaper than that. So our technology is the cheapest on-demand solar power. It's not the PV panels. It is concentrated solar power, or we call it solar thermal. Currently, there are some commercial technologies, of course, and the commercial technologies can go only up to 600 degrees C, and their thermal efficiency is around 85%, which is good, which is great. But we need to push this temperature rating higher and higher if we want to replace industrial heat applications like cement production, for example. Cement production requires 1,500 degrees C. So you cannot use you cannot use the current commercial technologies. You need to have something which can go higher in terms of temperatures. And our receiver does exactly that. Our receiver can go up to 1,500 degrees C because we are using the aerospace knowledge base, meaning that we are repurposing jet engines. Jet engines, if you look into jet engines and if you look into the commercial airliners, they fly all day long. They fly 20 hours every day, right? And in these 20 hours, the inner core of the engine is experiencing at least 1,200 degrees C continuously. And even the inner parts of it, combustion chamber, experiences temperatures in excess of 2,000 degrees C. Like it is extremely hot in it. And we are using the accumulated knowledge base from this, and we are operating and we are repurposing it for solar thermal industry. So we know what materials to use. We know the fatigue characteristics of those materials. We know how to design those materials, how to design those components, and how to operate them. So we are quite further down the line, I would say, and our results from from this graph, it is obvious that we have an advantage over the competitors. We filed 3 patent families, cementing our position in this market, and we have an operational prototype that is available for inspection in our Oxford lab. So it's very exciting time. Exciting times are ahead. We will replace combustion in the next 10 to 15 years. So what is the market right now? If you look into the market, the maturity is quite variable, and I would say the highest maturity and commercial scale application right now is large scale electricity generation by using steam turbines. And the market for this is quite large, but we are aiming to have smaller version of them, because our power plants can operate with supercritical carbon dioxide. This is also a new version of power cycle, and especially the US government put lots of money into this development because it is much more efficient. So for example, a supercritical carbon dioxide turbine will convert 50% of the heat into electricity, whereas a steam turbine can only convert 44% of it, 44% of it into electricity. But the big thing is, this guy, supercritical carbon dioxide turbine, can do it at 10 megawatt scale, whereas this guy has to be 50 megawatt scale at least. So this is a very important distinction between large scale and small scale. So this is for the electricity bit. The bigger market, as I showed in my second or third slide, is the on-demand heat market. It is extremely large market. It is a $1 trillion per year market, extremely large market, and of course you can produce pure water if you can heat up a media. So this you can have a boiler and you can produce water. The more exciting bits, I would say, the more experimental bits are the kerosene reactor. I'm not going to go into details of this, but this is extremely interesting because once you reach 1,500 degrees C, you can split water molecules into hydrogen and oxygen, and you can produce hydrogen right away by just using sunlight. And you can split carbon dioxide in the air in the same way, and you can produce carbon monoxide. And once you combine those two, hydrogen gas and carbon monoxide gas, you can start the production of hydrocarbons. So you can produce fuel, like any type of fuel, kerosene, diesel, or gasoline, or any kind of hydrocarbons, really, just from thin air. So recycling carbon dioxide from the atmosphere and using sunlight, you can start the production of any type of carbon-based fuels. So this is an extremely interesting from an engineering perspective project, and we have a small team in our company looking into that. So the market, as I said, all the 3 avenues, they are really large, and even for example, for solar on-demand heat, even assuming 1% of it will come from solar thermal, and actually I would say 90% of it should come from solar thermal, but let's say if it's 1, it's a market size of $700 billion per year. It is extremely large because 1/3 of all energy we are consuming goes to industrial processes to produce your plastics, to produce your cement, to produce your steel, to produce everything that you are using at your home, even the silicon that you use for your hardwares of your mobile phones, for example, or your computer. They require extremely high temperatures in their processes. So everything you use, we need to decarbonize those processes. And Odqa is strategically in the perfect place to decarbonize that. These are one of the largest plants that we consume this heat. And as you can see, these plants are like tower size factories, right? They're extremely large. We have around 200 steel plants in the world. So in the next 50 years, we have to replace each and every one of them with a carbon neutral or carbon free alternative. It is a big thing, and we don't have a technical solution for that yet. But it needs to happen. So as a starting point, what we can do is small scale. And small scale means small investment, small risk, and the technology implementation is much easier at small scale, and you can deploy it faster. So you can be first in the market. And when I checked the market size of all the small players, the one thing jumped to me, which is the brick production. Like ordinary bricks, you have a clay, you put it in a mold, you just fire it, you just heat it up, bake it in a furnace, and you just need to have around 1,200 degrees C maximum. And the fuel cost for this industry is around $70 billion a year. So it is a huge industry, and we chose this industry to be our minimum viable product. So we will start with the brick production, and then we will go for other kinds of production, first and foremost in ceramics, and then we will go to cement, we will go to steel, we will go to glass, and in the same way, we have a parallel work stream, which is the electricity. We are working with one of the largest OEMs in the world on this, and we conducted several feasibility studies, and the results are industry leading. So we expect that project to be to happen in the next 2 years as well. So this is a big challenge when you are trying to move so many things at the same time. You don't, as a small startup, you don't have that many resources, so you need to find ways to grow, and this can be done in two ways. Generally, you can some large player can buy you out and put more resources in, and you can have access to their distribution lines, their brand name, I would say, and the financial resources, or you can partner with them to grow this, and or even you can license your technology. So there are a couple of growth paths that we can explore. but we are quite flexible because our priority is to push our solution to the market, because as it stands, there are no viable solutions to a problem. And when there are no viable solutions to a problem, you cannot expect companies to decarbonize, right? You cannot expect an industry player to innovate and find a clean way of doing it from scratch. It is the duty of research facilities, governments to issue grants, and startups like us to innovate. We are blessed with very, very powerful investors and institutes that support us, and angel investors. I would like to mention a couple of them. This is not an exhaustive list of all. So OSI invested in our company, and OSI is the world's largest university-based venture capital company. They have 600 million pounds, and they invest in Oxford intellectual property. As I said, Oxford Thermofluids Institute, it is the largest engineering institute in Oxford, and it has a perfect knowledge base and experience in developing very complex engineering devices. Also, we have Oxford University Innovation, which is the Oxford University's technology transfer office. They help us with managing the intellectual property. Also, in the mid last year, we accepted some investment from Future Fund, which is UK government's investment vehicle. So I might say UK government is backing us as well. And we also received some grants from Innovate UK, which is also UK government's vehicle to invest, not to invest, to help to innovative companies like Odqa. Angel investors. So Mr. Fred Aziri invested in our company last year, and he's a very important person for the company, because he is helping us all the way. We regularly have strategy workshops with him and with Mr. Philip Lenoble. They both come from Goldman Sachs. They were investment bankers, very successful investment bankers. And Fred built his own startup, built it for 8 years, and then sold it for 350 million pounds. So he experienced all the life cycle of a startup. So he is advising me on how to manage the process. Philip has a wealth of experience, especially in infrastructure investments, and he is helping us raising finance and helping us how to think, how to look at the problem we have. And Mr. Akil Paul, he's an angel investor, and he's a part of a large and wealthy family in the UK, and they're in India as well. They have a conglomerate of companies, and he is helping us on how to develop, how to manage the business development side of the things. So this is it. This is what we are doing. I wouldn't say in a nutshell. But it might be as a summary.
Gediz, what an incredible work you and the Odqa team are doing, focusing on transferring the knowledge base of jet engines and developing a fusion reactor on Earth. Incredible work at effectively, efficiently concentrating the sun light and sun power and turning it into heat. As you said, we currently mostly use fossil fuels for the generation of energy and heat, something that may be easy, but it is not sustainable. And to some extent, of course, we use hydroelectricity, wind, and nuclear power. So in the effort to replace gas and coal, and at the same time be able to at least support our base need for energy, concentrating solar thermal energy appears to be key. Could you please expand a little bit more on the minimum infrastructure required and needed for the Odqa technology to be applied and used? What is needed to set up that minimum infrastructure?
Yeah, so our minimum viable product, I would say, is mirrors and a short power tower and a receiver. Once you have that, and once you have a small furnace, you can use sun's energy to heat up this furnace and start production of bricks, for example. This is extremely low tech, I would say, apart from the receiver that we are developing, and you can have mirrors right from the shelf. You can just buy them. You don't need to develop any. You can build your tower. It's a well-known method in construction, and you can construct your furnace as well. They're all there. So we just need to have this receiver, and we develop that technology. Once you have this receiver, you can use this sun's energy and start producing the bricks. Once you have these bricks, then you can develop other uses like ceramics. What kind of ceramics I'm talking about? The tiles that you are using at your home, the sanitary ware that you are using at your bathroom, the even the prosthetics that you are using in your body. There are lots of ceramics that you are using, engineering ceramics, different ceramics. So this is the ceramic family. This is our minimum viable product, and it's a multi-billion-dollar market on its own. But we are not only targeting ceramics. Once you have the ceramics, and once you have this knowledge base of operating solar thermal heat plants, then you can transfer this knowledge base into adjacent fields like plastic manufacturing. You can produce plastics, and that's a multi-billion-dollar market. You can go into glass manufacturing. You can go into cement manufacturing. All of those we need to decarbonize. And from our standpoint, we need to build solutions, and solar thermal looks like a really good solution to us.
And you also touched upon the various applications of the technology and the solution, which was actually the next question. How important? Can you please tell us a little bit more? How important are strategic partnerships in this process? In order for the Odqa technology to be applied and introduced in all the different areas that it can be useful at?
Yes, the strategic partnerships are probably the most important thing in our development, probably more than money or any type of financial connections. And the reason for this is quite simple, because you have, let's say, next 20 years. This is the window of opportunity. And if you want to do everything in series, like raising $10 or $20 million and investing in this, building a plant and operating it, it's a 5-year cycle. And if you want to do this 4 times, you only end up with 4 plants, right? So what you would like, what you prefer to do is partnering with incumbents, use their expertise in the developments. For example, partnering with a cement manufacturer, let's say, and use their knowledge base in cement production, and introduce this new concept, and they can then go and build 10 or 20 plants at the same time. And this is only for one industry. But if you don't have that kind of partnership, it will be extremely challenging for Odqa to scale it. So to scale everything and to make everything a success, we have to have partnerships.
And without any doubt, you guys are going to be able to confirm all of those great partnerships. Gediz, thank you very much once again for your time and for your presentation and for your participation at Leading Entrepreneurs of the World. You and your team at Odqa are doing an incredible job developing revolutionary technologies for the harnessing of solar power to turn it into thermal energy and for reconstructing the sun on the face of the earth. Congratulations on all of your progress and success. Thank you, and we look forward to speaking with you again soon.
Thank you, Stelios. Thanks for having me on board, and also doing the series so that my fellow entrepreneurs, colleagues can watch those things. And I've been watching your series, and I've been learning a lot, I would say. Thanks for everything.
Thank you. Thank you, Gediz.